Hey, what's up, my dear students? It's Naresh Babu. Welcome back to Physics Crush. Students, in this session, I'm going to discuss about center of mass. Let us start the class. Center of mass. What is center of mass? If you take any body, in that body, its whole mass appears to act at one point. That point is called center of mass. Look at the definition. What is center of mass? The point at which whole mass of a body appears to act is called center of mass. For geometrical objects, where will be the position of center of mass? For geometrical objects which are symmetry about their x and y axis have their center of mass at their center. Look at these figures. See, for this sphere, center of mass will be at its center. Why? Because the sphere has symmetry about its x-axis and y-axis. Like that, if you take this cube also has center of mass at its center because it has symmetry about its x-axis and y-axis. Same thing for this cylinder also. This cylinder has center of mass at its center because it has a symmetry about its x and y axis. That means if you take x and y axis, that x and y axis divides this cylinder into equal parts. Okay. Now we will discuss about position vector of center of mass. Look at this figure. Consider a system has two masses m1 and m2 which are located by the position vectors r1 and r2 from origin. We have to calculate center of mass of this system which has two masses. For that I have taken displacement vector. So the center of mass will be on the displacement vector. For the displacement vector, the location of center of mass with the help of position vector RCM I have located here from origin. Now we have to calculate position vector of center of mass. How we will calculate? Look at the formula. So here position vector of center of mass, that is m1 r1 plus m2 r2 by m1 plus m2. Then what about x and y coordinates of center of mass? So x coordinate of center of mass here m1 x1 plus m2 x2 by m1 plus m2, and y coordinate of center of mass m1 y1 plus m2 y2 by m1 plus m2. Now we will discuss about velocity of center of mass. So velocity of center of mass means derivative of position vector of center of mass. So we have to derive position vector of center of mass with respect to time. That is d by dt of m1 r1 plus m2 r2 by m1 plus m2. Then we will get velocity of center of mass, that is derivative of r1, we will get here v1. Same thing, derivative of r2 with respect to time, we will get v2. So finally we will get velocity of center of mass is equal to m1 v1 plus m2 v2 by m1 plus m2. Now we will discuss about acceleration of center of mass. So acceleration of center of mass means derivative of velocity of center of mass with respect to time. That is equal to derivative of, that means d by dt of velocity of center of mass means m1 v1 plus m2 v2 by m1 plus m2. Then we will get acceleration of center of mass, that is m1 a1. How we got a1 here? derivative of v1 with respect to t, that is a1, and the derivative of v2 with respect to t, that is a2. So finally we will get acceleration of center of mass m1 a1 plus m2 a2 by m1 plus m2. Now momentum of center of mass. So moment of center of mass is equal to product of mass, that is total mass of body, and velocity of center of mass, that is equal to total mass into velocity of center of mass. We know that m1 v1 plus m2 v2 by m1 plus m2. Here m1 plus m2 means total mass, so total mass, this m and this m1 plus m2 will be cancelled, then we will get momentum of center of mass, that is m1 v1 means p1 plus m2 v2 means p2. So we got momentum of center of mass, that is p1 plus p2. Now we will know about force on center of mass, that is total mass into acceleration of center of mass. So total mass into acceleration of center of mass, that is m1 a1 plus m2 a2 by m1 plus m2. Then here total mass m and m1 plus m2 will be cancelled, then m1 a1 means f1, m2 a2 means f2. So we got force on center of mass, that is f1 plus f2, that is force on sum of the forces of individual particles. Then another formula for force on center of mass, that is derivative of momentum of center of mass with respect to time. So that's about this session, my dear students. I hope you like this session. If you like it, please put like and share my video. Thank you, students. Bye, students.